Bismillahirrahmanirrahim. Assalamu alaikum. My name is Ali Aslam. I am from BS Biotechnology. My ID 34. Today my topic carbon utilization, carbon capture, and carbon storage. An approach to mitigating greenhouse gas emission. Now we turn to this introduction of carbon capture, carbon utilization, carbon storage. Carbon capture and carbon utilization and storage is a process that captures carbon dioxide emissions from industry process and power generation, preventing it from entering the atmosphere. The carbon captured carbon dioxide can be utilized in various forms. Stored underground to prevent its leak into the atmosphere. We are see that the overall the process of the picture: carbon capture, carbon utilization, and storage. And CCUS technology has been around for decades, but it has only recently gained attention as a potential solution to climate change. Yes, we know the CCUS technology is important in mitigating greenhouse gas emissions by capturing carbon dioxide from industrial process and power generation. This helps to reduce the amount of carbon dioxide released into the atmosphere. So let's discuss that CCUS technology has the potential to become a key tool in the fight against climate change and help to society transition to a low carbon future. CCUS technology has been around for the decade, but it only recently gained attention. We know that CCUS has become an important tool in the fight against climate change. Now we move to importance of CCUS in greenhouse gas emission. Yes, we speak that CCUS in the short form of the carbon capture, carbon utilization, and carbon storage. Greenhouse gas such as carbon dioxide contribute to global warming and climate change. We know that carbon dioxide is more dangerous for our health, for our atmosphere, for everybody living thing. Oxygen is most important thing for every person. Now, the brink of the fossil fuels industrial process and deforestation are some of the major sources of this emission. CCUS can help reduce the greenhouse gas emission by capturing carbon dioxide before it enters the atmosphere. In addition, now we move the second step. Importance of the CCUS in greenhouse gas emission. In addition to reducing the emission, CCUS can also have industrial transition to a low carbon economy by the capturing carbon dioxide and fly in the waste form, such as in hand oil recovery or oil production of the chemical materials and fossil fuels depend and promote the suitable practice. That's what discussed that continuous research and development of the CCUS technology is important to overcome the challenge, elimination, and that currently exists such as light cost, limited scalability, and the lack of the supportive policy and regulatory framework. With continued investment in research and development, CCUS technology has the potential to become the key tool in the fight against climate change. Yet, we again discussed that a key role tool in the fight against climate change and to help to society transition to low carbon future, high to low carbon future. And carbon action is transferred is therefore need to support the ongoing development CCUS technology ensure it is playing important role in mitigating greenhouse gas emission. Overview of the three components. Yes, we discussed the carbon capture, carbon utilization, carbon storage. Last, we discuss the one by one. What is carbon capture, what is carbon utilization, and what is carbon storage. The first is CCUS technology. We have discussed the overall the view of the CCUS technology. What is the CCUS? They are the main three technology used in the CCUS: carbon capture, carbon utilization, carbon storage. Carbon capture. What is carbon capture work? Carbon capture involves capturing carbon dioxide emission from the industrial process and power generation carbon utilization involved using the capture carbon dioxide in various forms, such as enhanced in oil recovery. Carbon storage involves storing the capture and carbon dioxide underground, preventing its release into the atmosphere. Each technology has its own challenge and benefit. Yes, we know that every person, every topic, every technology have Every technology has its own challenge and benefit. For example, carbon capture may be expensive, energy intensive, while carbon utilization can provide economy benefit. Carbon storage requires careful management to ensure the safety, effectiveness of the storage state. Let's discuss the first point of the carbon capture. This is the main point and the main key role for the carbon capture that raise our planet. Yes, carbon capture raise our planet. If carbon capture is not work, we are not do the well, we do not well operate. So that is our planet. Introduction of the carbon capture. Carbon capture is a process that involves the capturing carbon dioxide from industrial process or power generation facility before it's released into atmosphere. Carbon capture, we are now that the capture. What does capture mean? Capture means catch. Something wrong, things wrong, anything catch. Carbon capture is a process before entering the air atmosphere, the chemical product sheet is captured into the process. Carbon capture is reduced to greenhouse gas emissions and combat climate change by the preventing a large amount of carbon dioxide from entering the atmosphere. The technology plays a significant role in the reducing global emission. Okay, then we'll convert into next slide and we see the process of the carbon capture. Yes, we see that carbon dioxide involved into a machine form and remove the carbon dioxide and spend the very clear air for atmosphere via layer. There are three types of the carbon capture. Types of carbon capture. There are three types of carbon capture. First is the pre-combustion capture, and second post-combustion capture, and three oxy-fuel combustion. First, pre-combustion capture. What is pre? Pre-combustion capture involves removing carbon dioxide before fueling them. Yes, we know that. What is the mean of pre? Pre is the before. Every process before. For example, pre-combustion capture may be more efficient for some power plant. Yes, some power plant release many chemicals in the air, atmosphere that is very harmful, dangerous for our health. Yes, we see that coal, stream, air, ASU, and classification is forming, and in the process, it is all over the process. Yes, we see that carbon dioxide capture and carbon and recycle. It is very pre-combustion capture cycle is very beneficial for our health. And then post-combustion capture. What is meant post-combustion capture? Post-combustion capture involves moving it after fuel is burned. We know that what is post. Every person knows that what is post. Post is that when we post everything, post the shifting, post everything. So this is the name of post-combustion. When the process it come out. Post-combustion carbon dioxide using electrical chemical mediating amine generation. Post-combustion capture may be better suited for the other. It is you see that the picture of the carbon pre-combustion capture, carbon capture. Yes, it is cylinder of the carbon capture. They receive the and capture the and pour the combustion wall, the removing it after fuel is burned. Then we are converting to oxy-fuel combustion. This is the last three steps of the carbon capture. Oxy-fuel, what is oxy-fuel combustion? Oxy-fuel combustion involves burning fuel with the pure oxygen instead of air. It is a process of the combustion in which instead of air, it's burned the pure oxygen, which create a more concentrated stream of the carbon dioxide, which release the stream of the carbon dioxide and is easier to capture. If it is very process to easier the capture, we see that like the picture. Yes, you can see. And the next step, exploring the solvent and membrane in which the carbon capture involved. Distillation and solvent, they're the main different point of the exploring solvent. Distillation, what is the distillation? Distillation involved is a process to use the separate the mixture of liquid based on their boiling point. It involves heating the mixture oil, utilize the one component of the boil, and then consider it back in a liquid. Yes. Then solvents such as waters are commonly used in distillation. This choice of the solvent depends on the boiling point of the component being separated and dissolved in the solvent. Extraction is a process used to separate two compounds from the mixture using a solvent, and the solvent dissolved in the desired component, leaving behind the unwanted component. Common solvent. What is common solvent? Such used in extraction include water, ethanol, oxide. Acceleration involve water, ethanol, oxide. This is the difference, the main point. Acceleration. Membrane fertilization. What is the membrane fertilization? This involves the exploring the carbon capture. It is a process used to separate particle and molecule based on their size and chain. It involves passing a mixture through a membrane that allow only certain particles to pass through it. This is a mixture, a membrane, who allow only certain particles to pass through. It is separate in the filter machine that is allowed to the pass through it. Application of the carbon capture. There are the many applications of carbon capture, but is the most important that industrial process where larger scale carbon capture has been demonstrated and its commercial operation generation include coal, gasification, ethanol production, fertilization and production, natural gas processing, refining hydrogen production, and most recently coal-fired power. Yes, we see that and in the picture and cleared from the formation, the mean of filtration, trapping of the separated droplet, carbon dioxide dissolving into the water, physical contamination under crapola, carbon dioxide infection into the defense, deep swelling formation, carbon has divine enhanced oil recovery. Then the gas ethanol production, fertilization production, natural gas processing, refined hydrogen gas production, most incentive oil-fired power. Yes, we are now that the name of enhanced oil recovery (EOR) involved injecting carbon dioxide into the oil reservation to enhance oil recovery. The carbon dioxide acts as a solvent, reducing the viscosity of the oil, making it easier to extract. The process also results in the permanent storage of carbon dioxide in the reservoir. Coal bed. Yes, we discussed the coal. Now we could do that coal bed methane recovery. Coal bed methane, CBM, short name. Recovery involves injecting carbon dioxide into coal seam to extract methane, which is then used as a fuel source. The carbon dioxide remains stored in the coal seam, reducing emission to the atmosphere. And then with the fourth and fifth third point of the cement manufacture and chemical production. The cement manufacturing process produces a significant amount of carbon dioxide emission. Carbon capture technology can be used to capture the carbon dioxide emitting during the manufacturing process, which is then stored or used in the other application. A fourth point is the chemical production. What is the chemical production? Chemical production, the cement manufacturing process is produce a significant amount of carbon dioxide emission. Carbon capture that emitted during the manufacture process, which is then stored or used in the other application. There are just few examples of the current industrial application of the carbon storage. As we as this technology continue to advance, we can expect to see more widespread adoption of this and other carbon storage methods. Let's remove the next slide. And the second type of the carbon utilization. Carbon utilization is an important topic that has gained the significant attention in recent years. Yes, we are now there. In the recent year, carbon utilization is important to attraction because it's very popular. It involves the conversion of carbon dioxide into the valuable product such as fuel, chemical material. This process only reduces the amount of carbon dioxide in the atmosphere, but it provides a suitable source of energy. So yes, the human body use the energy source. Yes, we see that the structure, carbon dioxide capture, utilization, Sequential CCS, so carbon storage, enhanced oil recovery. We have discussed about that. Conversion do carbon natural fuel, chemical synthesis, carbon utilization, carbon mineralization, energy conversion. Yes, let's we move the next step. Methods of carbon utilization. There are the many methods of carbon utilization, but they are the most important method of carbon utilization. They are the three methods: chemical, biological, and mineralization. Let's discuss chemical conservation. Chemical conservation involves the conservation of carbon-containing compounds such as carbon dioxide, methane into the useful chemical and fuel. One of the most promising chemical conservation methods is catalytic reduction, which involves using catalysts to convert carbon dioxide and a gas into the chemical like methanol. The reaction typically occur under high pressure and temperature condition in the presence of heterogeneous catalysts like copper, zinc oxide. The catalyst work like breaking the bond between the carbon dioxide and H2 and facilitates the formation of the new chemical bond to produce a methanol. This is in a detail about the chemical conservation. Now we discuss the total about the main point and example with the chemical conservation. What is chemical conservation? Involved catalytic reduction of the carbon dioxide oxygen gas to produce the chemical like ethanol, plastic, and fuel. Example of the chemical conservation. Next step, the mineralization. What is mineralization? Let's we discuss about the detail of mineralization and overview about myself. Involves the conservation of the carbon dioxide in the stable mineral like calcium, magnesium carbonate. The process of mineralization typically occurs through a chemical reaction between carbon dioxide and mineral like olivine, titanium, and wallenite. The reaction is facilitated by adding water and other solvent, the mixture that can be facilitated by the use of mineral catalyst. The reaction condition for mineralization vary depending on the specific mineral being used, but generally require high temperature and pressure conditions. Mineralization, let's time it as a define of mineralization before we discuss the detail. Mineralization involves the chemical reaction between carbon dioxide and the mineral like aluminum trying to produce stable component. Example, the conservative stable component. But like the convert the unconservative to stable carbonate. Stable carbonate is the process of mineralization. Third point and the last point on the biological conservation. Biological conservation. Let's discuss about the detail. Biological conservation involves using microorganisms like bacteria, algae to convert the carbon-containing compound into useful products like buffalo chemicals. One of the most common biological conservation methods is fermentation, which involves using the earth to convert the sugar into ethanol. During fermentation, your cell break down the sugar molecule into smaller components like the pyruvate and acetylite, which are then converted into ethanol and carbon dioxide. The reaction occurs under the anaerobic condition and required specific pH and temperature conduction to be effective. Let's we discuss about the define. Biological conservation involves using the microorganisms like yeast to ferment the sugar into ethanol. Example of the photosynthesis. Biological process now the convert to mind the photosynthesis. Summary. It's all about the summary. Summary. Summary is the chemical behind each carbonization method involves specific catalysts and reaction conditions that facilitate the conversion of the carbon-containing compound into useful products. This method has the potential play significant role in the reducing greenhouse gas emission and mitigating climate change. However, there are the still challenge to overcome, including cost effectiveness, scalability, and energy requirement. This is a summary of the all over the process and the types of the carbon capture utilization. Industrial application of the carbon utilization. Yes, carbon utilization industrial application. The carbon and the oxygen in the carbon dioxide can be used as the alternative to the fossil fuel in the production of the chemicals, including plastic, fiber, synthetic fiber. Third type is the carbon storage. Carbon storage involves storing the captured carbon dioxide underground, preventing its release into the atmosphere. For example, carbon storage requires the careful management to ensure the safety factor of the storage site. This is we see that the storage site, yes, and careful management overall ensure that the careful storage site of the carbon storage. Method of the carbon storage. They are the many method of the carbon storage. The most important, there are three methods of carbon storage: geological stage, occurrence, and mineral. Discuss the geological storage. Geological storage, this is method involve capturing carbon dioxide from the industrial source, injecting into deep into geological formation such as depleted oil, gas reverses, saline formation. The carbon then trapped into the frost rock formation and stored permanently underground. Geological storage is currently the most widely used method of the carbon storage, with numerous anonymization projects in the operation worldwide. Is it worldwide? Yes. Example in the underground storage is a depleted oil gas reservoirs. And second is the ocean storage. Ocean storage. Ocean storage, one of the most promising methods of the air that captures chemical observation using material like amino material organic framework MOFs. These materials have high affinity for carbon dioxide and they observe it from the air. The carbon dioxide is released by heating the material under specific conditions, allowing it to be stored or used. Feedback. The reaction condition for the capture depend on the specific observed material being used, but generally require high pressure temperature condition. This let's discuss about the ocean depth. This this method involves injecting carbon dioxide into deep ocean water. Yes, this method inject the carbon dioxide into deep water, where is the storage the amount of dissolved carbonate as the suspended particle. The ocean can observe large amount of carbon dioxide, and the deep ocean acts has the potential to the store vast quantity of the gas for the long period of the time. For example, injection into deep ocean water. Example is the very deep injection into the deep ocean water. And then mineral storage. This method involves the conservation of carbon dioxide into stable mineral through a chemical reaction. Mineral storage means convert the carbon dioxide into stable mineral through a chemical reaction. One of the most promising material storage method is a carbonation, which involves the reacting carbon dioxide with naturally occurring mineral like oleosulfate and basalt. For example, carbonation of minerals. Summary. In summary, carbon storage methods such as geological storage, stage, and mineral stage are being developed to address the challenge of moderating climate change by has reducing greenhouse gas emissions. While each method has its own advantage and challenge, their combined potential for reducing carbon dioxide and concentration in the atmosphere is significant. This is a few examples of the current industrial application of carbon storage. As the CC technology continues to evolve, we can expect to see more research observation of this other carbon storage method. Application of the carbon storage. Enhance oil recovery. Even more injected carbon dioxide into oil receivers or to enhance oil recovery. Let's see oil before we discuss in the detail. What is the oil recovery? Carbon dioxide acts as a solvent. Yes, we know that carbon dioxide acts as a solvent. The viscosity of the oil making it is the extract. The process also results in the permanent storage carbon dioxide in the receiver. Coal bed manufactured on coil bed methane recovery involves injection carbon dioxide extract methane, which is then used as a fuel source. The carbon dioxide means stored in the core stream, reducing emission to the atmosphere. Challenge and future direction. Challenge and limitations of the CCUS technology include high cost both in the term of upfront capital investment, ongoing operational expenses, limited scalability due to technical and logistical constraints associated with capturing and storing large volume carbon dioxide from industrial operations. Lack of supportive policies and regulatory framework that create the incentive for the investment, remove the barriers to entry. Challenge ambitious this technology, high cost, but in terms of the upfront investment. Research and development focus on the developing more efficient and cost-efficient carbon capture and storage technology as well as new storage technology that can safely and efficiently store large volume carbon dioxide, development of new business models and funding mechanism to help overcome the high costs associated with CSS technology and policy regulatory framework being developed to create investment for CCUS implementation and move the barrier to entry. Effort to improve the CCS technology, effort to improve the CCS technology has spent domination include such development focus on developing more efficient, cost-effective carbon dioxide and storage technology, as well as new storage technology that can safely efficiently store large volumes carbon dioxide. Development of new business model and founding mechanisms to help to overcome the high cost associated with CCS technology, policy and regulatory framework being developed to create the incentive for CCS implementation and remove barrier to entry. This is discuss the effort to improve the technology and let's discuss about the before challenge and the future. Now, next last step of the my topic conclusion. All about the conclusion. CCUS technology is most important in managing greenhouse gas emission by capturing carbon dioxide from the process and power generation and storing underground oil and material. This will help to reduce the amount of carbon dioxide released in the atmosphere. That therapy help to reduce the challenge of climate change. Our car questions therefore need to support ongoing development of the CCUS technology and to ensure that it will play important role in moderating greenhouse gas emissions. Hope so you are well understand this my topic and thank you so much for to listen to me. And this is the link. We have helped the make the my side presentation and thank you so much. And this is the last step. The overall the process carbon sequestration means that carbon capture, carbon utilization, carbon storage, and the gas emission. They are the process. Now we see that in the detail. In the my presentation we are discussed in the detail every step. Thank you so much. Allah Hafiz. Hope so you are enjoying my presentation. Thank you.